So what we have is x squared minus 4 is equal to square root of x plus 2. And all this is asking us, when does this function, and we already know that's a parabola, right? When does this function equal that function? And that function, that side of the equation, is just a sideways parabola. Okay, anyway, we'll talk a lot more about these, but it just becomes a reflection about the y equals x line. Okay, so if we're graphing both these equations, this is what they're going to look like. Or graphing both these functions, sorry. Let's do this one first. When x is, let's pick some numbers that we know. This is a square root, so we're going to try to do perfect squares, right? So when x is 2, if you put x is equal to 2, 2 plus 2 is going to be 4, and the square root of 4 is 2. It's plus or minus 2, okay? So let's just do plus or minus for now. But we're going to eliminate the minus part because definition of a function is it has to only cross for every x. It can only be one y. So if we draw full parabola sideways, it doesn't become a function. So what we do, we eliminate the bottom. And again, we're going to talk a lot more about these when we hit polynomials. Okay. So this is just sort of a teaser of why the difference of squares, the equal sign, how this all fits together. So when x is 2, y is 2, plus or minus 2. So when x is 2, y is 2 and negative 2, but we're not going to put that point in there. When x is negative 2, if we put negative 2 here, negative 2 plus 2 is going to be 0, square root of 0 is just 0. So when x is negative 2, y is going to be 0. And this function goes off like this. Okay? So if you put, let's say you put x is equal to 7 here, what you're going to do is 7 plus 2 is 9, and square root of 9 is plus or minus 3, right? So if you go 7, 3, 4, 5, 6, 7, it's just going to be 3. 1, 2, 3. So it's going to be up here. So this graph does a curve or this function looks like this. This function, if we do a table of contents for this guy, if you put x is equal to 0, this is going to be 0, 0 squared is 0, 0 minus 4 is just going to be negative 4. So when x is 0, y is negative 4. When x is 2, 2 squared is going to be 4, 4 minus 4 is 0. So when x is 2 plus 4 minus 2, y is going to be, or this side, this function, because this is just a function, it's just a y, right? If we call this f of x and we call this h of x, f of x equals this guy, h of x equals this guy, right? So if you sub in x is equal to plus or minus 2, 2 squared is 4, negative 2 all squared is 4, 4 minus 4 is 0, so this just becomes 0. So we have 3 points here. 0 and negative 4, 0 and 1, 2, 3, 4. And we have 2 and 0 and negative 2 and 0. So when x is 2, y is 0. When x is negative 2, y is 0. So what we have right now is answering the question, when does this function cross this function? Well, at this point, we know at negative 2 and 0, they both cross. So at that coordinate system, both functions are crossing each other, or hitting each other. And at that one, to be able to solve it, we'd have to square root both sides, and we're going to do a whole bunch of these later on. But graphically, it's going to be at x is equal to 2 point something, 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 because it's a little bit past 2, okay? So that's what the function means. That's what it means when you say, what is something equals something, okay? When it comes to difference of squares, if you have functions that you can factor out, sometimes it becomes simpler to do. All you do is you grab this whole thing and move it over. For this type of question, it's easier not to do that. There are other types of questions that we talked about, where x squared is equal to 4, you can grab it and bring it over. And what that does, we solved it for x squared is equal to 4, right? So what we did was, draw our parabola, drew a horizontal line, and found out where the parabola or quadratic function crossed the horizontal line, right? The other way that you can solve that question is move the 4 over and bring it over so it becomes x squared minus 4 is equal to 0 and factor it out. And what happens for that, if you're graphing that function, that standardizes your solutions. It brings them down to the x-axis. So what it does, this was a parabola for the other one, but it was shifted up, right? And the horizontal line was up here. So we're actually dealing with two different functions, right? F of x and h of x, or f of x and h of x, right? If we want to solve it as one complete function and forget about h of x, all we do, we bring the 4 over and solve it, and what we end up getting is our parabola. And whenever we're factoring something, whenever we're solving an equation by factoring, we talked about this in series 3a, what we're doing is finding the x-intercepts. So what that would do by bringing the 4 over, the equal sign for the previous question, it would shift our parabola down, and all of a sudden our solutions become the x-intercepts, and that's what we're looking for. And for a lot of functions, for a lot of questions, it's easier to solve for the x-intercepts than not to solve for the x-intercept. You can punch this into your computer and graph one, graph the other, and grab the x-intercepts, right? And there's a lot of schools in my area anyway, they use the graphing calculators, and all you do, when they say solve for this, if they say you can't use a calculator, you got to do it manually, and we'll talk about that. If they don't say you can't use a calculator, all you do is punch that in as your y1, punch that in as your y2, let the computer, let the program, let the calculator graph it, and all you would do is just grab their intercepts, where they intersect each other, and that would be your solutions for these questions, which is basically asking you at what x-coordinate do both functions equal each other? At what x-coordinate do both y's equal to each other, right? So when does y1 equal y2? When does this function equal the other function? And we'll talk a lot more about this when we start getting into polynomials.